So this is a video to help us review skill 7, completing the square, before we do the reassessment coming up in class. So use these examples to help remind you about some of the mistakes we made on the EOK, and then do some of the practice problems on Desmos. So here we go. We are asked to convert each trinomial to vertex form, and we're going to use completing the square to do so. So if we look at number 1 here, all right, first thing I'm going to do is I'm going to rewrite it this way. I'm going to leave my first two terms, x squared minus 4x, and I'm just going to put plus 9 over to the side. Our goal with completing the square is to figure out what number we need there to make it a perfect square. So I'll draw our picture. I've got 4 x's, so I'm going to put 2 on each side, which means I have 1, 2, 3, 4 that I need to add to complete the square. So I want this to be a plus 4 right here, all right, which means if I add 4 there, I also need to minus 4 there. So remember, the number we're adding to complete the square, we also have to subtract to keep our expression the same value. Okay? Now, these 3 terms represent the area of my square, which I can also represent as x, and then it's minus 4x, so this would be a minus 2 times x minus 2. So I'm going to rewrite that as x minus 2 squared. And then these 2 terms, minus 4 plus 9, is going to combine to plus 5. So there is our vertex form. Okay. Another way of looking at it is some people think about it like this. They say that, okay, I have 4 squares, and I want to get to 9 squares because my expression has plus 9 in it. So to do that, to go from 4 to 9, I need to add 5. Okay? Either way is fine. We just got to make sure we are accurate with our number that we're adding or subtracting at the end. Let's look at another example. Okay. I'm going to start the same way. I've got x squared plus 12x minus 6. I'm going to say x squared plus 12x. I'm going to leave the minus 6 off to the side because we know we're going to have to add some sort of number in there. When we draw our diagram, we have 6 x's on each side, which means 6 times 6 is 36. So to make this a perfect square, I have to add 36. But to keep my expression equal, I need to minus 36. These 3 terms represent the area of our square. We could also write them as x plus 6 squared, because it's x and 6 x's on the side. And then minus 36 minus 6 combines to minus 42. And if you're someone that does it the second way, the how many do I need, how many do I have, in our diagram we have plus 36 at the end, but we need to get to minus 6. So what do I need to do to get from 36 to minus 6? Right, I have to subtract 42. So here is our vertex form. And last one, when we have a coefficient in front, right, that's not 1, so in this case we have 2. Right? In that case, all I'm going to change is that I'm going to have 2 squares. So I'm going to rewrite it 2x squared plus, whoops, it's minus 20x. I'm going to leave some space, and then I'll say plus 15. So in this case, when I draw my 2 squares out, I have 20 total, but I'm going to have 10 on each. So then I would have 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. This squared of 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. And for each of those, I'm going to have to add 25 to make it a perfect square. All right, which means in total, to make this 2x squared minus 20x, I need to have plus 50 to make it a perfect square. If I add 50, I need to subtract 50. So then I have 2 times x. It's a minus 5 because it was a minus 20x squared. And then minus 50 and plus 15 would combine to minus 35. If you're someone that likes to do it the other way, in our perfect square diagram, we have 50, or we have 50 in the 2 squares. But our expression, we only want 15, so to get from 15 to 35, or sorry, 50 to 15, we have to subtract 35. So there is our vertex form. Play the video again if you need to, but go ahead and get started on the Desmos practice.